Okay, AP Calc kids, there are two more series tests. The one I'm going to be doing in this lesson, and then there is one more. Okay, this test is called the alternating series test. Now, think about that, what that means, alternating. By alternating, they mean alternating in sign. Okay, so let me give you a definition first. An alternating series is a series whose terms are alternatively positive and negative for consecutive terms. That means one after the other. Okay, so for example, let's say we had 1 minus a half plus a third plus a fourth, minus a fourth. Minus a fourth plus a fifth, yada yada. Okay, that series would be represented as the series from 1 to infinity of negative 1 to the n plus 1. That is the alternator. That's what's going to make this alternate, of 1 over n. Okay, this is actually called the alternating harmonic series. And you should know that, just like the regular harmonic series is 1 over n. Okay, so remember, the regular harmonic series diverges, okay? But the alternating harmonic series converges. You'll see the test in a minute. But you are allowed on the AP exam, if you see the harmonic series, you're allowed to say that the series diverges because it's the harmonic series. And if you see the alternating harmonic series, you're allowed to say that the series converges because it's the alternating harmonic series. Just an FYI. Okay, so that is an example. Now let's look at the test. And you're allowed to call it AST, alternating series test. If A sub n, now A sub n is the positive part, all right? You'll see in a second. Is greater than 0, then the alternating series n equals 1 to infinity. Remember, the bottom index doesn't matter. Negative 1 to the n of A sub n. So when we're talking about A sub n, we're talking about the alternator not being included. Or the series equals n equals 1 to infinity of negative 1 to the n plus 1, a to the n, converges if both the following conditions are satisfied. And here they are. Number 1, the limit as n goes to infinity of A sub n, that means, okay, the absence of the alternator. Is equal to 0, so you need that. And then 2, the series itself is a decreasing okay, or it could be non-increasing, same thing. sequence. Okay, that is that a sub n plus 1 is less than or equal to a sub n. So that means that the terms are decreasing in magnitude. That's what this means. Terms are decreasing in magnitude. So that means they're absolute values. Okay? So they're decreasing in magnitude for all. By the way, the symbol for all is like this, if anyone cares. If you ever see this in a math, something you're reading in math, that just means for all. For all n greater than k, for some k, okay, that is the element of the counting numbers. All right, so what this means is that it doesn't have to be decreasing in the beginning, guys, but we're talking about end behavior, okay? So this means end, okay, not beginning. So it could start off that they're not decreasing for like the first 3 or 4, and then they're decreasing. We only care about the end behavior. Let's look at an example. Oh, by the way, I need to point this out, okay? Note, this does not say that if the limit as n approaches infinity of a sub n does not equal 0, then the series diverges by AST. This test is only used for convergence. Okay, so that's extremely important. The AST only tests for definitive convergence. All right. So keep that in mind. Now, if the limit of a sub n does not equal 0, right, then the series diverges, but by the nth term test. Remember that? If the limit as n approaches infinity of a sub n does not equal 0, then the series diverges by the nth term test, the series a sub n. Okay? That's only, so the nth term test is only used for that if you're talking about a positive series. Okay, pause the video and copy down these 2 examples and come back. So for the first example, what I'm trying to say above, okay, is that you don't have to use the AST because the limit as n approaches infinity of n over 3n minus 1 is not equal to 0. It's equal to 1/3. Okay, so therefore this series, I'll call it a sub n. Therefore the series, you know what? I don't want to confuse you here with this circling this. I'm going to call this part a sub n. Therefore the series -1 to the n times a sub n equals 1 to infinity, diverges by the nth term test. Okay, so you cannot use the AST test for divergence. That's the whole point. cannot use AST for divergence to test for divergence. Okay, now this one over on the right, this here is an alternator because sine, as you put in integer values, right? Oh no, sine is just going to be, I'd have to make this pi over 2. Okay, so as you put in integer values, sine is going to change sign. So this is an alternator. So when I get rid of the alternator, I can do the AST. So now here's how the AST works. So I would have to say that the limit of 1 over n as n goes to infinity is equal to 0. And then I would have to say that a sub n plus 1 is less than a sub n at some point, or you could just say the words, okay, the terms are decreasing in magnitude. So you have to have both of these parts. Either one. So since we have these, both of these, therefore the series sine n pi over 2 divided by n converges by AST. Okay, we'll be continuing this in class. All right, guys, thanks.